Okay, today we're going to look at solving when all we have is variables, or at least we have more than we want to deal with. Okay, so here's an equation. This should be a form that you're familiar with. This is point-slope form. So if you remember back to graphing, this is called point-slope form. And when we graphed, we ended up with y and x by itself, but we have our point, x1, y1, and we have our slope m. There's nothing special about it right now other than I just wanted to use something you're familiar with, so this is again point-slope form. Now our directions here say that we want to solve this for y. I should have wrote solve, but we're going to solve this for y. And our immediate problem is I don't know what any of these numbers are. So we can't assume what they are. We can't assume they're things like the number 1. You got to treat them like numbers, but they're an unknown number. It can be any number in the world, and you got to treat them like it can be any number in the world. But they are numbers. So we can do things like add, subtract, multiply, and divide because we're allowed to do that with numbers. Okay, so just like we did with our multi-step equations, we're first going to identify where our variable or variables are. And in this case, I'm trying to get y by itself, and I only have one of them. It's right here. This is a different number, y1, so we get to treat it like something else. The y is right here. And if I want to get y by itself, I'm going to have to get rid of this y1. And I generally don't like parentheses, so we're going to get rid of the parentheses as well as we clean it up. Okay, so the easy way to get y by itself is simply to add y1 to both sides. But let's take care of the parentheses first, just because I want to show you how to do that. Okay, so we're going to rewrite the left-hand side, y minus y1. And what we do before with the distribute property is we're going to take what's out front, and we're going to distribute it to everything inside. And we're going to do that through multiplication. We're still going to do that. We're allowed to do it. This is a number, that's a number, that's a number, so we're going to go ahead and do that. So we're going to do m times x. Well, m times x is simply m times x, and we write it as mx. Then I'm going to do m times x1. Well, it's m times x1 is the number m times x1, or mx1. And the minus stays in between them. So I've now distributed successfully the m because I can't actually multiply it, but I can write out that it is multiplied. And the way I do that is writing mx, and the way I write the second one is writing mx1. Okay, so I've multiplied these two numbers. I have a multiply and a multiply, and the minus sign stayed there. And at some point, if I'm given what m is, I could figure out what these numbers are. But in the meantime, I can't, so I'm going to leave it alone. Now I go over here. I want to get rid of a minus y1. Anytime I subtract a number, I do the opposite, so we're going to add it. And if I do it on one side, I'm going to do it on the other side, so I'm going to add y1 to the other side. On the left-hand side, if I add y1 and I take it away, that's number 0, which is, of course, what I want, and I'm left with y. So I'm almost there. Now I got to do over here. Well, I would normally combine like terms. So I don't know if y1 is like mx. My guess is not, because that's an x. I don't know if y1 is like mx1. My guess is not, because that's an x1. So I'm simply going to write it. So I'm going to rewrite what I have, mx minus mx1, and I'm going to add y1 to it. So again, I can't actually do any of this arithmetic, but I can write that that's the arithmetic I need to do, and that's all we're able to do, is we're going to write mx, subtract mx1, plus y1. And if sometime in the future I end up with some numbers in here, then I'll be able to do some more arithmetic. But right now, that's our answer, because that's the most we're allowed to do until we know more information. So that's what solving with all variables looks like. Let me give you some more simple examples just so you can see a couple more, because this is one of the more difficult things we're going to do right now. So let's give you something from science. Let's say F equals ma. This happens to be a force equation. You don't have to worry about that right now. What's important is that you end up with 3 letters. This is force, this is mass, and this is acceleration. And let's solve it for, I don't know, let's solve it for m today. Okay, so our goal is to get m by itself. So the first thing is we identify it. M's right there. And I want to get rid of something that's with it, and that's, of course, the a. I don't care about the f because it's on the other side of the equal sign. So we're going to get rid of the a, and I first have to decide how to do that. Well, I have m times a, because 2 letters next to each other is always times. How do we get rid of a times problem? Well, we divide. And we're going to do the same thing. So if I want to get rid of a times a, I have to divide by a. And whatever I do on one side, I have to do it on the other side. So even though I still don't know what a is, I know that I want to get rid of it by dividing. And if I do it on one side, I got to do it on the other side. Okay, on the right-hand side, I have a divided by a. And any number divided by itself is always the number 1. So I have 1m, which is, of course, just m. On the left-hand side, I can't actually do this division because I don't know what f is and I don't know what a is. So I'm simply going to write it as f over a. And now I know what m equals. It is the fraction f over a. Okay? Let me give you one more. So let me open up another tab. Just give you one more example. This is a common one you're going to see a lot. Let's say I get a line in standard form. So how about ax plus by is equal to c? And I want to solve this for y. And I could pick anything I want, but we often solve it for y. Okay? So our first step is we're going to subtract ax from both sides. And the reason we're going to do that is because, of course, I'm looking to get y by itself, and here's y right here. So just like any other two-step equation, I'm going to identify the things that need to move. What needs to move is the ax and the b. Okay, so we're going to move this ax, and if I want to move this whole thing, I'm just going to subtract the whole thing. So I still don't know what this number is. It's a multiplied number. Say it's 2 times 3. Well, if I have 2 times 3 and I subtract 2 times 3, I get 0. If you don't believe me, let's try it. 2 times 3 is 6. 2 times 3 is 6. 6 take away 6 is 0. So it doesn't matter what a and x are. All it matters is I'm going to subtract a times x because this will be 0 no matter what a and x are. And if I do it on one side, of course, we got to do it to the other side. So this a and x is going to cancel with this a and x, and it's gone. And I'm left with by. On the right-hand side, I see a c, and I see an ax, and I see no reason that those are like terms. So we're simply going to write it. So I got c, take away ax. Okay, the next thing I need to do is I still need to get y by itself. Remember, this is a times problem. Yes, I know it says by, which is kind of interesting, but that's just by coincidence. This is a times problem. I need to get rid of this b. We're going to do it by divide because it's a multiply problem, so I'm going to divide. And if I do it on one side, I have to do it to the other side. And when you divide by everything. So we're going to divide this whole thing by everything. On the left, I got b divided by b is 1, so I'm left with y. And on the right side, I end up with c minus ax over b. And since there's nothing else I can do over here, because I don't know what it is, I'm going to just leave it as c minus ax over b. There's a couple other little tricks we can do over here, but right now, let's not worry about it too much. I am perfectly happy if you leave it like this. Okay? So if you have any questions, let me know. This is another one of those skills is you're just going to have to get your hands dirty and practice it. And when you practice it, you're going to start running into things that you're not 100% sure on, and that's when you need to be asking for help. Let me know when you get those questions.